We are learning something new today. Rolle's theorem and MVT. So you'll recall way back when I said, if a theorem has its own name, it's importante. That's Spanish for important. Therefore, today we're not getting just one, but we're getting two named theorems. And they're related to each other. I believe his first name was Michel. Michel Rolle was a mathematician, French, and he came up with a theorem. Oh yeah, I forgot. Okay, hold on. Yeah, we're going to do Rolle's theorem. Yep, then we're going to do the mean value theorem. Yep, then you should be able to count to 10 in German. Anybody? 9. Nicht sehr gut, meine Schatzi. Was ist los?
Da.
That's Russian, you doofus. Ja. Ja, ja, ja. Und nein. Ja, ja und nein. Wunderbar. Ja, sehr gut. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, you're allowed to speak German in the American schools.
Wait, can you count to 10?
Can I count to 10?
German?
You just did.
I just did.
Oh.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 10. You gotta be careful nothing comes flying out on that one. Okay, so here's what Rolle said. You know what, let's just get right into this. There's what Rolle said. So I'll give you the calculus speak, then I'll give it to you in English. Let's break it down. What do you notice first about f? It's continuous. Does that mean it's differentiable? No, so it then goes on to tell you, oh wait, it's differentiable. So is Michel Rolle being redundant? Is he repeating himself? Is he saying the same thing over and over again?
No.
You sure?
Yes.
If it's continuous, does it have to be differentiable?
No.
No, but if it's differentiable, does it have to be continuous?
Yes.
So isn't he kind of beating a dead horse by saying it's both continuous and differentiable? Could have just said it's differentiable. But he got all fancies in his fancies. We're on an interval from A to B, including A and B. And if that's the case, oh, also we know that f of A equals f of B. What does that mean in English?
Two numbers have the same output. Two inputs have the same output.
Good. What does that mean graphically?
It has the same.
You got a 50-50 chance. X or Y values.
Same way.
Good, they have the same Y values. So we're starting, if we take these 2 points, A and B, which are X values, in order for this theorem to work, they have to have the same Y values. Okay, that's our hypothesis. If that's true, if we have that set up, then f prime of C equals 0 at least C in the interval. What does that mean in English? What does it mean when f prime of C equals 0? It's a critical point, which translates how graphically? What does a critical point look like on a graph?
So relative min, relative max.
Perfect. Okay. Now, there's a nice, easy way to remember this, which involves a picture. Let's suppose you have level ground, and a point here, A, and a point here, B. That satisfies our initial condition. A and B have the same Y value. They're on the same level ground. And then in the middle of this business, we put a hill. You could also do a valley, but we'll do a hill because it's easier to explain. Now, you take a big honking boulder. And you roll that boulder up the hill. See what I'm doing with this? Yeah. You roll the boulder up the hill, and then you roll it down the hill back to level ground. Logically, you should be able to visualize the fact that somewhere it's got to hit the top of the hill. Does that make sense? Okay, now imagine A and B weren't at the same level. Here's A down here. Here's B up here. Would Rolle's theorem still apply? Could I create a hill from A to B in the second scenario where it never hits the top of the hill? Yeah. Yeah. Correct. So this doesn't work. That's why Rolle is the one that recognized that they have to start at the same level. So again, when you're visualizing this boulder rolling up the hill, you've got to imagine that you're starting and stopping at the same level. You're starting on flat ground and then rolling it up a hill. You could also roll it into a valley if you'd like. And the valley would say that at some point it's got to hit the bottom of the valley. Correct. Does it only hit one top of the hill? I don't know if that makes any sense, right? Notice this little term here, at least. Could it hit more than one? Yeah. So if you imagine like rolling a boulder up a camel's back, we could have something like that. And that boulder would hit two different maxes. And in fact, not only would it hit two different maxes, it would also hit a minimum somewhere along the way.
It's like a story that Grassy told us in physics last year.
Oh, share.
So like you was driving one time and he had a stick shift car, right?
Right.
So he like,
Mr. Grassi,
oh,
how awesome that you just happened to be walking by.
Eating an ice cream sandwich.
nice.
That's okay, we don't judge.
Roll A.
So Paul said that last year in physics you told a story about driving a stick shift car up a hill?
Yeah.
Could you share?
Sure.
Does it apply to Rolle's theorem?
No, it's more the intermediate value theorem. That's what I would say. Remember the intermediate value theorem?
Yeah.
Do you? If I have a function value here and I have a function value here, and the function is continuous, it means I hit every function value in between. I'm driving up, hill at the top of the stop sign, get up, put the clutch in, roll backward a little and go. I get pulled over. The policeman says you didn't stop at the stop sign. I said, well, I rolled into it. Did you see me roll backward? He said, yeah. I said, well, in between rolling forward and rolling backward, there had to be an instant, and there where I was stopped. And the policeman said,
Why do I have a feeling there's a punchline to this?
no, it's true, right? Am I wrong?
This is a true, no, I understand the theorem applies, but did you really tell this to a cop? Or does it end with like?
No, 100%. And the
Okay.
policeman said, you know what? Since velocity is continuous, a continuous function, the immediate value theorem does apply. You've got a positive and a negative, so it's in between there must be a zero. Did he say that?
No.
He was a policeman. He said,
What are you saying, policemen can't know calculus?
no, he didn't calculus, but he didn't
I'm just
say
saying,
that.
I mean, you know.
He said a very policeman thing. He said, I'll give you a warning. Now, did I say, wait a minute, I don't even deserve a warning because of the intermediate value? Did I say? No, I said, thank you. By the way, who was it? Miss Van Hoy. Anybody know who Miss Van Hoy is? We just had lunch. She was talking about baking 2 pies. And I asked her, does it have to be at 360 degrees? Sorry.
Making, wait, I missed that. Making 2 pies. The shame of it is we recorded that for prosperity's sake. Oh, boy. Okay. Okay, so do you understand the concept of Rolle's theorem? All right, good. But again, there's a couple small things to remember that are really important. The first one is that you have to start and stop at the same level. So f of A has to equal f of B. And you have to at least hit one max or min. You could hit an infinite number. Okay, but again, Rolle didn't care how many, he just said at least one. So there it is in English, which we already did. Okay, so let's talk about this. We'll look at a function that we can easily visualize. Zach, what can you tell me about that function?
It opens up
Good. How do you know that?
because the first coefficient is positive.
Good. What's it look like?
It's quadratic.
Good.
It's a parabola.
Good. So you would think, being a parabola that opens up, we should get a minimum somewhere, right?
Yeah.
There's a problem, though, in that we have an interval. So we don't necessarily know if that minimum that you knew how to find from pre-calculus, you could do negative b over 2a and all that other gum, we don't necessarily know if that's going to fall into that interval. So what we're going to do is take a calculus approach to this instead of a pre-calculus approach where we would do negative b over 2a. So Rolle's theorem says that you have to start and stop at the same level. Well, do we know we're starting and stopping at the same level? I need to know what f of 1 is, and I need to know what f of 2 is. And in this case, they're the same value. They're both equal to 0. If you go back here and plug in 1, you'll get 0. You plug in 2, you'll get 0. That establishes that we're starting and stopping at the same level ground. Now we're either going to roll this boulder down into a valley or roll it up over a hill and see if we hit the maximum. Well, is this function continuous and differentiable? Casey, you're shaking your head yes. How do you know?
It's a polynomial.
Beautiful. And all polynomials are continuous, and it's differentiable because, no, careful. Because we know it's a parabola, so we should be good to go. Parabolas are differentiable. So then we need to find out where f prime of c is equal to 0. Take the derivative, set it equal to 0, and solve. We get 3 halves. Is 3 halves in our interval? Yeah, so we're good to go. Rolle's theorem doesn't necessarily tell you where it happens. It just tells you it's got to be in there somewhere. Okay, then you have to go and do your calculus stuff to figure out where that is. Take the derivative, set it equal to 0, so. What if it's not in the interval?
So if we get like for this 3 over 2, that's where the like lowest point is. Like the same.
Well, it's either the lowest point or the highest point. Now, we happen to be, you're all fairly bright, so you realize from what Zach told us it opens up, so we know already it would be a minimum. If I give you some different functions, you won't necessarily know if it's a maximum or a minimum. That's tomorrow's lesson. Tomorrow's lesson is going to answer one simple question. Is it a max or is it a min? Okay. Does that answer your question?
Yeah.
Beautiful. Okay. Now, Rolle's theorem was the precursor to this big one, the mean value theorem. If you're going to forget one of them, forget Rolle's theorem. But just don't forget it. The mean value theorem does something nice that Rolle's doesn't do. It takes out that chunk of having to start or stop at the same level. It just allows us to take any interval. And it's a little different, but you'll see as we get to it. Okay, so still have to establish that it's continuous and differentiable. Or establish that it's differentiable, because if it's differentiable, we know it's continuous. Then we're going to do that business. Can you explain that business to me? What's going on there?
You're finding this slope.
Of? Let's deal with the right-hand side of the top equation. So instead of dumping this on no one, let's work on this together. We've got a function, and we're on the interval from A to B. What does f of b minus f of a over b minus a represent? And I hear a lot of people whispering slope, but slope of what? No, not a tangent line. Secant line, correct. It's the slope of the segment or the line connecting the two endpoints of our interval. Okay. What's the left-hand side of the equation?
The tangent of
Say that again.
what would be the tangent line when you plug
What about the tangent line?
Is the equation of it?
No. Slope of the tangent line. Okay. So the mean value theorem is kind of nice because there's a real easy buzz phrase to remember. The left-hand side of this equation says that the slope of the tangent line has to equal the right-hand side of the equation, which is the slope of the secant line. Somewhere in the interval. Okay, and I've got a picture. Once you see the picture, it'll fall into place, but you should also try to visualize what's going on there. I have some function on an interval. So I take the two endpoints and I draw a segment connecting those two endpoints. I can find that slope using simple algebra. The mean value theorem says somewhere in that interval then I have to be able to find a tangent line that has the same slope. And for some reason, people like to write it like this second line, and I don't know why, because that makes no sense to me whatsoever. I mean, it makes sense to me. I understand how they got it. I just don't know why you would use that as the mean value theorem. The top one makes more sense to me. What even makes more sense is that buzz phrase. The slope from calculus has to match the slope from algebra somewhere in that interval. Okay, the slope from calculus comes from taking the derivative. The slope from algebra comes from doing a simple y2 minus y1 over x2 minus x1 slope calculation. And the picture explains everything. So I've got this parabola with 2 points on it, A and B, there's my interval, and I connect those 2 points with a line. That gives me that secant line there. That's the right-hand side of the equation. The mean value theorem says somewhere between A and B then, I have to have a tangent line that has the same slope. Okay? Does that make sense? It'll make a little bit more sense if you're confused. It'll make a little bit more sense when I start showing you some examples. Because there's nothing up there that you can't do. Are we good to go before I proceed? Okay, let's do it. Now again, I'm cheating a little bit because I'm dealing with parabola, which we know quite a bit about, but we'll pretend we don't know anything about a parabola. Is that function continuous and differentiable? Yes. Okay. Good. Then mean value theorem will apply. We have an interval from 2 to 7. Step number 1, find the slope of the secant line using algebra. You might want your calculators, by the way, to bust those out and figure out what f of 2 is and f of 7 is. I wish I would have known that. I would have asked her. I heard a rumor that there's really cool magnets in Georgia.
She goes there like very often.
Oh, so there's other opportunities. Because last time I looked, no Georgia magnets.
But her text her. She's still there.
Just saying. All right, we got a slope. You just run it. You just ran like a random math facts. You're like Rain Man. Yeah, 72 minus 12, 60. Yeah, 60.
I was just thinking like, because you can do 2 times 2 is 4 times 20, or times 5 is 72 minus 30 times 2.
Okay. So what's the answer to my question? Oh, so you're just shouting out numbers. I gotta do the math?
Huh?
What's the slope of the secant length? For math? What's the slope for algebra?
I'm figuring it out.
Okay. Actually, you have it? Lauren, do you have the slope of the secant line?
Yeah, 15.
15. Anybody else 15?
Yeah.
Golden.
Wait.
Okay, so
The slope of the line.
y2 minus y1 over x2 minus x1. F of 2 minus f of 7 over
We're
2.
taking tangent, alright.
No, not yet. Hold on there, Hoss. Okay, we're in the neutral. Okay, so 15 represents our slope from algebra. All right? That's the slope of the line connecting 2 and 7 as our endpoints of the interval. That means that somewhere there's got to be a slope of a tangent line that has the same value. So take the derivative, set it equal to not 0, but, what did you say it was, 15? 15.
When did you switch back into mixed numerals?
Oh.
Yeah, he was mixing numerals for like 6 years.
4.5. 9 halves. Beautiful.
45.
Both of you got 10x minus 30 as the derivative, yes? So where's x? 4.5. Yeah, 4.5. Beautiful. Any problem with that? Is 4.5 in the interval? Yes. So I've got some parabola facing upward, connect the 2 endpoints, I get a secant line, somewhere in there, it's going to have a tangent line, and that tangent line happens at when x equals, that tangent line happens when x equals 4.5. Okay. The difference then between MVT and Rolle's theorem is that Rolle's theorem requires that you're starting at the same point. So we have to make sure that f of 2 equals f of 7. Here we don't care, because we can take non-horizontal values and still calculate the answer. Let's try a different one. So I've got a function, 5 minus 4 over x. Do me a favor, on your calculator or using your iPad with Desmos, graph that function, because I think there's more to it than just that. I don't remember, to be honest. Because we want to talk about differentiability and continuity. In other words, is that function continuous and differentiable? So let me ask my question again. Is that function continuous and differentiable? No. So now what? We done? Where are the asymptotes? There's one at 0, and then isn't there a horizontal asymptote in there too? Or did I miss that? Yeah, it looks like there's a horizontal asymptote at 3 or 4, somewhere in there. In general, f of x is not continuous and differentiable. We've got some asymptotes, therefore we have an infinite discontinuity. However, the question I should be asking you is this function continuous and differentiable on the interval from 1 to 4? Yes. Okay. Which is why I have only that chunk of the graph. Are we good to go 1 to 4? The answer is yes, then we can proceed with MVT and we're fine. So what I've got set up then is MVT, the slope from calculus, f prime of c, is equal to the slope from algebra. Right? Calculate this, please. In fact, do the whole thing. Take the derivative, set it equal to the slope from algebra. Tell me where C is. Where does that function have a tangent line equal to the slope of the secant line? While you're working, I need to tell you, we need to talk about 2 orders of business. The first one, and most importantly, is tomorrow is Tuesday. Are we covered?
Yes.
Thought I heard a yes.
Yes.
Tomorrow's Tuesday, are we covered?
Oh, yeah.
You're on it? Are we having it tomorrow or Thursday? Yeah. So we're gonna go for tomorrow. Okay, second of all, we might have a visitor tomorrow. If he does come in to visit, just ignore it. Mr. Beloff. Maybe, I don't know if he's coming tomorrow, if he's coming 4th or 6th. Yeah. So try to keep your swearing to a minimum.
I only promise to try.
What'd you say?
I only promise to try.
No, well, that's all I ask. That's all I ever ask. Just try your best. That's it. I mean, things happen.
No, I totally forgot that answer, man.
All right, any progress?
Yeah.
Share. Two?
Plus or minus?
Plus or, oh. What was that case?
But no, but it's not even interval.
Oh, I don't know.
It'll only be positive.
Uh-oh. Hold on. Oh, what?
Slow your roll.
Who just said that?
What?
Slow your roll. Brilliant. I'm totally stealing. You didn't even realize it, did you? Slow your roll. Get it, rolls? Yeah, I'm totally stealing that. Okay, so finding the slope from algebra, hopefully you found the slope being 1. Take the derivative, set that equal to 1, and we get, as Tim mentioned, plus or minus 2. Okay. But then you said something else after that.
That it can only be positive 2 because that's in the constraints.
Awesome. Yeah, when you jump over to -2, it's not in the interval we're talking about, so you just ignore it. That's something you want to check when you're done. Regardless of how many answers you get, it doesn't guarantee that everyone's an answer because it has to be in the original interval. In fact, it's possible you could get 2 answers and neither one of them works because they're outside the interval that we're referring to. Okay, so a couple things to notice about this problem. First of all, we don't care if the entire function is continuous and differentiable. We just care about the interval of that function. Second thing is make sure to check your final answers that they're in the interval that we're referring to. That's a bridge that I believe is in Singapore. I'm not 100% sure. But for some reason, they decided to put the mean value theorem across a bridge. And I'm totally jealous.
New York to Singapore.
They're matching.
New York to Singapore to go to one to
How long is it?
They just had their native,
How's that?
I got a lot going on. I'm a mover and a shaker, you know.
As a
What's your problem?